So we are looking at Leetcode 392 is subsequence, and this is going to be building off of that work that we've been talking about previously in this data structures and algorithms series. So hopefully you've seen the last video where you have a solid understanding of some of the logic and how to approach these coding interview questions. So let's jump into this one. We're given two strings, s and t, right? And we would just want to return true if it's a subsequence, else we're going to return false. So what is a subsequence? The Leetcode explanation is here, but I think it's a little bit convoluted, and we can simplify that by just checking out an example. So if we look at example 1 that we're given here, s is equal to a, b, and c, and t is equal to a, h, b, g, d, and c, right? So essentially, a subsequence will be if all of these characters that we're seeing here in A, if all of these characters exist somewhere in T in the same order that they are in S, right? So if there's letters in between, like you can see A is here and B is here, but we've got an H in between, that doesn't matter. We can just ignore that H, right? And then we can see here we have a C, but G and D are in the way. That doesn't matter. We can just ignore G and D. And so we can see that, yes, A is here, right? B is here, and C is here. So yes, S is a subsequence of T, because A, B, and C exist in T in that order, and we just ignore the characters in between. So that's essentially what a subsequence is. So knowing that, we can break down this problem and try and tackle, okay, how do we actually solve this problem, right? How do we actually implement this problem into code? So what we'll end up doing is we'll be using a counter. That's kind of the common naming convention for it in Python. Of course, like always, you could call it whatever you want, but we'll call it I call it tracker. Let's say, right? Let's call it a tracker. So essentially, what we would do is we'd have our tracker value here, and we'd start with it set equal to 0. So essentially, the way that we're going to iterate through T and compare the characters in S and find out if our characters in S are in T is we're going to utilize this tracker. And the way that's going to work is we're going to leverage the fact that if we set tracker equal to 0, right, and then we were to say S tracker, right, let's say we set S tracker, what would that be equal to? Well, that would be equal to A, right? If we were to call up that S tracker value, right? Because in A, B, C, A is at the 0th position, B is at the 1st, and C is at the 2nd, right? So knowing that, what we can do is we can do a for loop, right? Very, very easy. We would do a for loop, right? And we would say something like for chars in T, right? So we would be looking at all of the characters in T. We'd be stepping through them, through T, and we'd basically be saying, is the position at S tracker, is that equal to chars, right? Is S tracker equal to chars? And so basically what we're saying here is, so in this case, we'd be iterating through, the chars would be representing the various values in T as we're stepping through them, and so we'd be comparing their value. And so we'd be saying, is A equal to chars, right, in this case? So we will step through, and so we would say, okay, yes, like in this example, in example 1 that Leetcode gives us, we'd start by looking at A, and then we'd be saying, okay, now we're going to compare, is S tracker, in this case A, is that equal to chars? And so we could say, yes, chars here and chars in T, looking at the characters in T, we have A, and so yes, A is equal to A. So what we will then do is we will take our tracker, and if that's the case, we're going to take our tracker, right, and we're going to set it to plus equal 1. We're going to increment 1. So tracker, in this case, would now be B, would be the letter B, right, because tracker is now equal to 2, right? Tracker now equals 2. And so this would be, if we called S tracker, now this would be equal to the letter B, right? And so now we're iterating through chars, and we're looking for the letter B in T. And so once we find it, of course, we would then, tracker would then be updated to plus equals 1, and then we would look for C, and so on and so forth, until we've iterated through all the characters and we've either found a match or we haven't, right? So hopefully that makes sense. I think once you see it in the code, it will kind of clarify everything for you. The explanation can be a little bit strange and make it seem a lot more complicated than it actually is. So we'll just jump over to Leetcode now, and we'll see what that solution looks like. And we're going to code up that solution based on the example and those notes that we took earlier. So what's step number 1, right? We want to define our tracker that we talked about so that we can keep track of those values that we've seen in T and make sure that they're equal to the values that we have in our string S, so we can confirm it's a subsequence, right? So our tracker is set equal to 0 to start off with, because we want to start with the first character in S. And then we want to look at all the characters in T so that we can do our comparisons and check the subsequence, right? And then we're going to say if S tracker, like we talked about, if S tracker is equal to chars, then we want to update the value of tracker to be plus equal 1, right? So that we can check the next letter and then check the next letter, so on and so forth, right? And then we're going to do our return, and we're going to say return tracker equal to the length of S, right? Because if tracker is equal to the length of S, then that would be, then if that's true, then we would, we would return true. This is just basically, this is doing sort of like a logical operation. So it's going to say if, basically when we call this return tracker equals length, if that's true, it'll return true. If it's not true, it'll return false. So that way we don't have to say return true or false. That function will just do it here by default. And so the only other thing that we need to do here is we need to make sure that we can actually break out of our for loop. We don't want to end up in a sort of infinite for loop here. So we need to just have a condition that'll say that if our tracker is equal to the length of S, we want to break, right? We want to break out of that, that for loop so that we don't just keep going through it infinitely, right? So if our tracker is equal to our length, similar to what we have down here, then we want to break out of it. So that means that we've seen all of our characters and we're good to go. We're good to take off and get out of our for loop. So let's run this and just make sure that it works. And it does. So you can see here that it's really, really efficient. I didn't mention it in the notes, but this is working in O of n time, and I can write it here. It's O of n time, and it is O of 1 space, and that's where n is the length of our strings, right? So this is going to be done in O of n time, O of 1 space, and yeah, you can see here that it's very, very efficient, and the code is probably easier than you thought it was. That explanation could have been a little bit more confusing, making the problem seem tougher than it is, but essentially it's just leveraging this tracker, and you can see here iterating through our loops. So code is very simple. So thank you so much for watching, and we'll see you in the next video.